Hey, section 9.5, effects of changing dimensions proportionally. So in chapter 7 earlier, we looked at how changing dimensions of a shape can result in a similar shape, and you can predict the new perimeters and or areas based upon what was changed and how it was changed. So in this section, we're going to look at that also, but a little more specifically, we're going to try to find specific formulas that we can use to make predictions about when a shape is changed. What will the new shape look like? What will its dimensions and areas and perimeters be equal to? So let's start with this triangle. Base of 12, height of 5. So the perimeter, it's a right triangle, 5 and 12. This should be a Pythagorean triple. Hypotenuse would be 13 inches. So the perimeter, 5 plus 12 plus 13, that'd be 30. So 30 inches. The original area, 1/2 base times height, 1/2 12 times 5. So 1/2 of 12 is 6. Oh, it's also 30. Okay. Now let's take the triangle and we're gonna multiply the height by 6. So now a new triangle over here. Base is still 12. This is horribly not to scale. 5 times 6, height of 30. And then real quick, I'll use Pythagorean theorem to find the hypotenuse. So square root of 12 squared plus 30 squared. Oh boy, so 32.1311. So 32.311, add 30, add 12. Our new perimeter is 74.311 inches. Our new area, 1/2 base times height, 1/2 times 12 times 30. So 1/2 of 12 is 6, 6 times 30, 180 inches squared. So you see a little relationship here. The 30 to 180. To get that, you would multiply by 6. And hey, that would be multiplied the height by. From 30 to 74.311. Who knows? Okay, so when one dimension is multiplied by 6, the area changes by 6. The perimeter, who knows? Look at example 2. What happens to the perimeter and area of the following rectangle when the base and height are both tripled? So our original perimeter, 4 and 4 and 7 and 7, 8 and 14, that's 22 feet. And the area, base times height, 7 times 4, 28 feet squared. And I just got nervous. I wrote feet squared. I really hope I wrote inch squared in the last example. Okay, good, I did. Okay, good. Just couldn't remember right away. I'm like, oh no, did I do that? So the new rectangle, the base and height are both tripled. So 7 tripled, 21. 12, or 4 tripled is 12. I feel like I'm leaning off the camera like I'm writing. I feel like I'm in here. That's no good. I'm here. Okay. So the new perimeter, 21 to 21, that's 42. 12 and 12, 24. 42 and 24. 42 and 24. 66. And for the new area, we need 21 times 12. Well, 21 times 10 is 210. 21 times 2 is 42. 210 is 42. 210 is 42. 210, 42. 52. Good, I did all right. 252 feet squared. Now looking at the perimeter relationships, from 22 to 66 times 3, what both our dimensions were multiplied by. 28 to 252, divide those. 252 divided by 28, you get 9. So to go from 28 to 252, you multiply by 9, or 9 is 3 squared. So if both dimensions are affected, our perimeter is affected, that each dimension is changed, then the overall dimensions are changed the same. But the square unit, when that change happens to the base and to the height, that change happens twice. So 3 times 3, 3 squared, or 9. Take a look at example 3. Kind of do what I've been doing in these examples. Then the table, go ahead and fill that in the best you can. And check my completed note when you're done. See how you did.